According to new research, the eruption of the underwater volcano in Tonga in 2022 may actually cause global temperatures to rise. This increases the chance that at least 1 year in the next 5 will temporarily go over the 1.5 degrees Celsius warming threshold. On January 15, 2022, the underwater volcano Hunga Tonga-Hunga Ha'apai in Tonga erupted violently, sending huge plumes of soot, water vapor, and sulfur dioxide high into the air. Most volcanic eruptions typically cool the planet temporarily because sulfur dioxide particles reflect sunlight away from the planet until they dissipate. However, according to the study published in Nature Climate Change, the Tonga eruption in the South Pacific ejected an unprecedented amount of water into the atmosphere. Because water vapor is a greenhouse gas, Hunga Tonga-Hunga Ha'apai may cause a temporary increase in global surface temperatures over a multi-year period. According to a study, there was a 50-50 chance that global temperatures would exceed the 1.5 degrees Celsius above pre-industrial levels at least once by 2026 before the eruption. The authors emphasize that temporarily exceeding the 1.5 degrees Celsius threshold does not imply that the Paris Agreement target for long-term temperature trends has been missed. However, the paper claims that the first year that exceeds 1.5 degrees Celsius will garner significant media attention, even if a portion of this is due to Hunga Tonga. On the Volcanic Explosivity Index, the explosion got a 6, which means it was the most powerful eruption anywhere in the world since Mount Pinatubo in the Philippines in 1991. The explosion was heard 6,000 miles away in Alaska, triggering tsunami waves that reached Russia, the United States, and Chile. The highest plume ever recorded from a volcano was 57 kilometers of ash, gas, and water ejected into the atmosphere. The eruption's ash blanketed nearby islands, forcing many people to flee to the main island. In the immediate aftermath of the eruption, ash and tsunami waves affected approximately 84% of Tonga's population, and 2 Tongan nationals were killed. Aside from these local effects, the Hunga Tonga-Hunga Ha'apai significantly differs from its predecessors. When a volcano erupts, these plumes of dust and aerosols typically reflect sunlight away from the planet, causing surface temperatures to fall. For a clear view, when Mount Pinatubo erupted in 1991, global temperatures dropped by 0.5 degree Celsius. The Tonga eruption, on the other hand, has had the opposite effect. The study's lead author is Dr. Stuart Jenkins of the University of Oxford's Department of Atmospheric, Oceanic, and Planetary Physics. And he explains that the Hunga Tonga-Hunga Ha'apai plume caused surface warming due to its unusual composition, saying that most large eruptions are dominated by sulfur dioxide emissions, which temporarily cool the planet by scattering incoming sunlight. The Tonga eruption was unusual in that it emitted a large amount of water vapor into the stratosphere, which is a powerful greenhouse gas, while emitting very little sulfur dioxide. Pinatubo and Tonga may have opposite warming responses, making the Tonga volcano especially interesting in the context of other recent eruptions. According to the study, the blast emitted only 0.42 million tons of cooling sulfur dioxide aerosols into the stratosphere, which is the layer of the atmosphere that begins around 10 kilometers above the Earth's surface and extends upwards for around 40 kilometers. Meanwhile, it emitted 146 million tons of water, increasing the stratosphere's water vapor content by 10 to 15%. Dr. Mark Schoberl, a Columbia University researcher who led a separate analysis of the Tonga eruption's water plume, said the Tonga eruption was definitely unusual, and according to him, Hunga Tonga-Hunga Ha'apai lifted an unprecedented amount of water into the mid-stratosphere. Dr. Louis Milan of NASA's Jet Propulsion Laboratory has also led separate research into the hydration of the stratosphere caused by the Tonga eruption. According to him, the eruption released enough water into the stratosphere to fill about 58,000 Olympic-sized swimming pools. This water vapor then spreads across a large portion of the stratosphere, and the warming effect of water vapor outweighed the cooling effect of sulfide aerosols, causing temporary rises in global surface temperatures. Scientists have studied the volcano's impact extensively since its eruption in January 2022, including the unprecedented height of its plume, the impact on atmospheric circulation, and the effect on global energy balance. This study, however, is the first to look into what the temporary warming means for global temperature thresholds. These authors used a radiative transfer model to determine how the Tonga eruption affected the balance of energy entering and leaving the Earth's surface. And they discovered a warming effect of 0.12 watts per square meter immediately following the eruption. They then used a climate model to project global temperature change over the next decade, assuming that the water in the stratosphere decreases linearly from January 2022 to January 2029. The authors then ask one question: what does this temperature rise mean for the 1.5 degrees Celsius warming threshold? The World Meteorological Organization estimated last year that there is a 50-50 chance that global temperatures will temporarily exceed the 1.5 degrees Celsius warming threshold in at least 1 year between 2022 and 2026. This estimate, however, does not account for the warming effect of the Tonga eruption. Professor Pascal Salido of the Inter-University Laboratory of Atmospheric Systems also published separate research on the Tonga eruption's radiative impact. He tells Carbon Brief that the study is a very interesting extension of the previous studies on the climate effect of this exceptional eruption, with very reasonable results. He does, however, point out 2 areas where the study could be improved. To begin, he claims that the paper assumes that the water vapor injected into the atmosphere is globally well mixed, whereas the plume was confined to the southern hemisphere. Second, the paper ignores the cooling effect of injected sulfate aerosols into the atmosphere, claiming that the sulfur dioxide deposit is significantly smaller than the accompanying water vapor deposit. Salido, on the other hand, claims that the Hunga Tonga perturbation of stratospheric aerosol is the largest since the 1991 Pinatubo eruption. Normally, January is in the middle of the dry season, but when the Tongan volcano erupted in the South Pacific Ocean and sent a huge amount of water high into the atmosphere, researchers now believe that Hunga Tonga-Hunga Ha'apai has messed up the normal pattern of water in the atmosphere of the planet. They say that the water from the volcanic eruption should be closely watched, both to predict what will happen in the near future and to learn more about how future eruptions might change the climate of the Earth. Tatsumi's findings of a volcano that's been exploding for tens of thousands of years show that the study of Hunga Tonga-Hunga Ha'apai is still in its early stages. The average temperature of Earth is close to 1.5 degrees Celsius above what it was before industrialization. This is the goal set by the United Nations in the Paris Agreement. The United Nations delivered the Paris Agreement in 2015, an international agreement to limit global warming to 2 degrees Celsius above pre-industrial levels, with a goal of keeping warming below 1.5 degrees Celsius. Since then, these temperature thresholds have served as key indicators of progress in addressing climate change. The paper predicts that the first year that exceeds 1.5 degrees Celsius will garner substantial media attention. It emphasizes, however, that the common interpretation of this agreement is that its temperature limits refer to a long-term global warming caused by human influence and not the additional effect of natural climate variability caused by events like volcanic eruptions. From this, temporarily exceeding the 1.5 degrees Celsius threshold between 2022 and 2026 as a result of the Tonga eruption will not determine the success or failure of the Paris Agreement. Jenkins tells Carbon Brief that the eruption's impact on global temperatures will be temporary and will fade over the next 5 to 10 years. He continues, "Today, Tonga contributes only a very small amount to the surface temperature anomaly, and maybe we will not see Tonga's impact on climate change events such as droughts or floods because the effect is simply too small."